Welcome back to Algebra 1. So we're going to take a look at another way of solving quadratic functions. We're actually going to switch into Chapter 9 because I think it'll make more sense to see all the different ways of solving before we figure out how to graph the darn things. But graphs can be very useful. Now you've already worked on one of the go-to ways of solving quadratics. If I can factor it, yay, do it. But we also will end up using graphs. And if we can see the graph, we can see where the solutions are. So there's a lot of different words that we use for the solutions. We often will say the roots, the zeros, the x-intercepts. All of those things mean the same thing. The solutions. Now, the reason that they're called the zeros is because if we look on a graph where the graph crosses the x-axis, y is 0, and that's a solution. So we could end up saying if this equation were equal to 0, which is exactly what we did when we factored, then these two places on the graph are the zeros. They're the solutions. Sometimes we also call them roots. A couple other terms that you'll hear me say. One of them is axis of symmetry. So if we take a look at this dashed pink line here, the graph is symmetrical across that. So if I go over 2 from this point, over 2 here. I go over 3 from about here, over 3 in both directions. So line of symmetry. The other point that can be very important and can be a type of solution is called the vertex. It is where the graph turns around. At this particular point, it's the point 2, -4. Both of those things could be things we're asking for, but that's going to be a while. Not every quadratic function has a solution. So the most common ones, and the ones that I've been showing you so far, are 2 solutions. Sometimes it only had 1 solution when it was a perfect square. But this can also happen if we take a look at our graph and it never crosses the x-axis. There's no real solution. We're going to start saying this word here, no real solution, for a reason, but that also will be a little while. So we already know how to factor. And when we factor, we found the 2 things that multiplied to give us C, add to give us B, set them up as factors, set them equal to 0, and solved each of those. If we have the graph already, we can work backwards from the graph and write the factors from where it crosses the x-axis. So right here, it crosses at x equals 2. So if I move that over, I'm going to have x minus 2 as a factor because that would equal 0. On this side, when I have x equals 6, if I wanted to write that as a factor, it would be x minus 6. So I have solution or 0, factor, and then I could FOIL that if I need to. But that would get me the equation that we end up having up here. When we have solutions, those solutions are not unique in that there's only one equation that goes through both of those. There's actually a lot of equations that go through those. Because I can make the entire graph steeper, still goes through those points, but it's steeper. Or shallower. I could have it very shallow. but it still goes through those 2 points. The only thing that is different between those is a greatest common factor. So we can factor things out. Everything in this red equation that's a steeper equation, when we look at these numbers, they're all divisible by 3. That's the greatest common factor. The greatest common factor will go in front right here. And when we have our factors, it goes in front. It doesn't affect our solutions. So I can do a couple things. Sometimes my graph goes through wonderful numbers and I can get exact solutions. On some of these, I'm going to have to make an estimation because they don't go through my exact points. In this particular case, I see that x equals -3 and x equals -1. I'm literally looking at the graph. I'm looking at these points right here and x equals. And the exact solutions. So in this case, it looks like I'm going through -5. And I can also place this as a comma. This is a +2. So x has 2 solutions. If I see the graph already, these are pretty nice. Now, this isn't perfect, is it? And if I really look closely between -2 and 3, I don't think it goes through 1.5. I think it's a little bit different than that. So I just have to make my best guess here. So if I'm dividing this up, I'm thinking that's at about 0.6 away from the 1. So I'm going to call that -1.6. And here, it really doesn't go exactly through the halfway point. So I'm going to call that -4.4. You are estimating. It's not going to be perfect. You'll have a slightly different answer than your friends will. The goal is do your best. These are some of the problems that if an estimate works, we're good, but we're going to have to find other ways to getting the more exact solution. So let's take a look at the black line first. And on the black line, I'm not going through exact points here. And I don't feel like I'm going through -1.5. I think I'm also going to call this -1.6. And then this looks like it's the same distance over. So I'm going to call this +1.6. And for the red graph, if I take a look at it, it only has one solution right here. So for the red graph, my solution is 0. It actually has 2 solutions, but they're both at 0. So right now, we just write it as 1. Later on, we'll see where those can be important, but not for right now. So part of this method is maybe it's not graphed. And we will eventually find a whole bunch of ways to graph these things. But for right now, we always can start with a tried and true t-table. Remember that we're looking for the zeros. And in a quadratic function, it can go way off the graph really fast. And don't worry about changing your scale because it just goes off the graph there. It's actually okay. When we are setting these up to solve, never forget about PEMDAS. Exponents come before multiplication. It's a real easy place to make a mistake. With negative numbers, this set of parentheses is vital. You really have to have it there. The calculator will happily give you the wrong answer if you don't have these parentheses on. So a negative squared, you gotta know is positive. With those reminders, so we can have this t-table. And for right now, we see these numbers are pretty general spots. And we might have started at the 0. Notice over here, what we do is we take this equation, we plug in the negative numbers in parentheses, plug it in, and then over here we're going to do our number crunching. This is going to be positive 9 plus negative 9, 0 minus 1. That's where we get the negative 1 here. These are all equal. I will often write it out because then it's easier for me to number crunch. I see here I've got 4 plus a negative 6 minus 1. That's where we got the negative 3. And we like seeing this particular thing right here. Negative 3, negative 3. And now we're going back the other way. So when we start graphing these points, we're going, hey, good. We kind of found the turnaround point. And if we went a little bit farther, notice this point right in here, we see the number changes from negative to positive. That's where we're going to find our 0. We know that it's helpful in our graph to have the axis of symmetry. It's got to be halfway between those two negative 3's. So if I had this guy over here, I know I'm going to be even over here. So those are a couple clues that kind of help us get the graph. If you had started with 0, then 1, and then 9, do you notice how our numbers are getting big way off the graph? That right there would have been our clue. I better start going the other way. So it's perfectly fine to start with your 0, 1, 2, and then look at how fast your numbers are changing. You want to go towards this shallowing out U section. So once we have it graphed, we're looking at these points right here and here. And I'm going to notice that I kind of jiggled when I drew this graph. But it looks like, I would say maybe a third. So I would say here, x equals, I would say 1/3 and negative and 1/3. You might have picked a quarter. You have to look at your graph, come up with your best guess. You're probably not going to find it perfectly. That's okay. We're just looking at doing our best. So here's one that we have. And I'm going to go ahead and start with 0, and 1, and 2. And over here, I'm going to write it out, plugging it in. And then once I do this, 0 squared minus 4 times 0, hey, that's 0. Yay, I found one. And when I plug in my next point, okay, we plugged in 1. 1 squared is 1, minus 4 times 1. 1 minus 4 is going to be negative 3. Plug in my next point. 4 minus 8 is going to be negative 4. Now, I've done 3. My decision is, which way do I keep going? Am I going to go to negative 1 or 3? What I want to look at is, where are my numbers closer together? That's the direction I'm going to go. So because these are getting closer together, I think I'm getting closer to my U, so I'm going to keep going here. Plug that one in. Now we have 3 squared is 9. 9 minus 12 is negative 3. Hey, I found that I turned around. So I'm going to keep going in that direction, hoping I can get to 0, plugging in a 4. And this is 16 minus 16, so that is 0. So I've done 5 points. That's not bad. I'm going to go ahead and plot those points. So I have 0, 1 to negative 3, negative 4, negative 3, 0. So just do your best to to draw the curve. It takes practice, believe me. Especially when you're drawing with a mouse. And once we have this graphed, we know that x equals 0 and 4 are our solutions. Next one. Still going to start with my 0, 1, and 2. At least if I'm plugging those in, those are kind of small numbers. I've written along the side, plugging these in, and then if I take a look at this, 0 squared plus 0 minus 1, this is negative 1. 1 plus, this is 2. 3 minus 1 is 2. 2 squared is 4 plus 4. 8 minus 1 is 7. And now I need to make a decision. Which way do I keep going? My numbers are closer together here than they are here. So I should go on the opposite direction to try to figure out where I'm turning around. Now I do have one solution here because I have a number change. Once I get over here, plug these in. Okay, they're plugged in, so now I'm going to take a look at these. Negative squared is positive 1. 1 minus 2 minus 1 is going to end up giving me negative 2. Negative 2 squared is 4 plus negative 4 minus 1. This is negative 1. If I go one more, this is 9 minus 6 minus 1. This is going to end up giving me 2. So I have both of my number changes going on here. I'm ready to graph. So at negative 3, I'm at 2. Then negative 1, negative 2, negative 1, and then I go all the way up to 7, and drawing with a mouse. So we have our drawing. What do we have as solutions here? Since we're here, and I know I jiggled here, I know it's a little bit less than that. This one I did a better job on. I don't know, I might say negative 2.4. And over here, I bet it's probably 0.4. Your numbers might be slightly different than mine. That's okay. I'm looking for, did you solve correctly? Graph them. If you notice that your graph did something funky, double check one of your answers. You have an assignment that's on a worksheet right now. That's before we do section 9.2. And